Hi, I'm going to present our work, Learning Reasoning Mechanisms for Unbiased Question-Based Counting. This work was done with Remy Caden, Shinlei Shen, and Matthew Cord. We are addressing the issue of biases. They prevent models from learning the correct reasoning mechanisms. For instance, most bananas are yellow, so it can be hard to detect blue bananas. This issue is important as biases can be harmful when deploying models in the real world. We address this issue in the context of the question-based visual counting task. This task is a subset of visual question answering. It is about answering counting questions on images. Questions can be simple, like how many people are there, or more complex, like how many giraffes are going to the left. Like VQA, this task requires visual understanding and reasoning. And this task, also like VQA, contains a lot of biases and shortcuts, which enables models to correctly answer questions without learning the correct counting mechanism. In TeleQA, the biggest counting dataset, we found many shortcuts. For instance, the words "are roaring" with a cat in the image are statistically associated with the answer 0. The model might learn this shortcut and fail on different images, such as the one on the right, where a woman is wearing a red shirt and holding a cat. We designed an experimental protocol to penalize models that rely on biases. It is composed of two splits of the TeleQA dataset. The first one, TeleQA-CP, is similar to VQA-CP. We modify the distributions of answers conditioned on the main word to be counted. This dataset penalizes models relying on question biases. Secondly, we introduced the TeleQA odd-even dataset. The training set is composed of mostly odd counting labels, while the testing set mostly of even counting labels. This dataset will effectively penalize models relying on multimodal shortcuts involving the image as well. Models that learned the correct counting mechanism should generalize to new count distributions. We evaluated state-of-the-art models with our protocol. Expectedly, a question-only model performs extremely badly on TeleQA-CP, close to 0% accuracy, and also badly on the odd-even split. RCN, the current state-of-the-art on TeleQA, also performs very badly on our two benchmarks. Especially, it performs worse than the two random baselines following train and test distributions. Next, we introduce a simple model designed to learn the correct counting mechanisms. The main design choices we introduce are the following. First, we give one score for each detected object instead of predicting directly the final count. So we merge each visual object and the question representation using a bilinear fusion. Then we apply self-attention to perform relational reasoning, and the results are merged again with the question to obtain a final score. Second, we train the model using a regression loss, which is more suited to counting tasks. Finally, we add an entropy regularization term to the final object scores to enforce low entropy sparse predictions. We show that our SCN model obtains much higher score on both our TeleQA-CP and TeleQA odd-even, demonstrating its ability to learn the correct counting mechanism. Finally, we show the importance of the entropy regularization loss. It makes the object selection sparse and the model more interpretable. We can see that for the how many giraffes are shown, it selects two bounding boxes associated to the giraffes, while the model without entropy regularization selects partially many bounding boxes. And we see similar results for the question, how many zebras are shown? To conclude, it's critical to test models' reliance on shortcuts before deploying them in the real world. And we showed that adding architectural and learning priors can help mitigate biases. Thank you for listening, and you can find more experiments in our paper.